Club's 2021 Solution Challenge. The Solution Challenge is an annual contest that invites students to develop solutions utilizing one or more Google technologies. This year's mission is for students to solve for one or more of the United Nations 17 Sustainable Development Goals. Check out the next video in this series to learn more on these 17 goals and how to brainstorm ideas to help achieve them. For now, let's take a look at the complete timeline of the Google Developer Student Club's 2021 Solution Challenge. The steps can be grouped into 4 phases: register, learn and build, deep mentorship, and demo day. At this phase, you'll join a Google Developer Student Club virtually at your college or university. If there is no club at your university, you can find the nearest one to you by checking our online directory. If you are joining a club outside your university, make sure to team up with at least one student from that university in order to be eligible to participate in the Solution Challenge. Once you are a Google Developer Student Club member, it's time to register your interest at goo.gle/Solution Challenge by submitting the form. Now you can form a team with up to 4 students from your club. Ideally, your team members will have a varied set of technical and soft skills, so you complement each other's strengths. The next phase is where you'll select one or more of the UN 17 Sustainable Goals to solve for. And now it's time to start defining and building your solution. We've created a series of videos to guide you through this process. They offer references to many technical resources available to you, so be sure to check them out. And remember, while you design and build your solution, you can always get guidance and assistance by posting a question on the mentorship platform Partheon, where Google developer experts can help you overcome the obstacles you face along the way. Once you have built your solution, gone through user feedback, and reiterated your code, it's time to record a demo video. The video should be 2 minutes or shorter and showcase your solution in a clear and exciting way. Both your solution and the demo video should be submitted by March 31st through the Solution Challenge website. At this stage, the Solution Challenge team of judges will review and rank all the submissions from around the world. You can check the judging criteria on the Solution Challenge website. The top 50 solutions will be announced and invited to join the deep mentoring phase. This phase is designed to fine-tune and improve the top 50 solutions. These top teams will receive mentoring from Google and Google developer experts. Once completed, these top 50 teams will resubmit their improved solutions and their improved demos to compete for a spot as one of the 10 finalists. These top 10 teams will win an array of prizes, among which are a 1-year subscription to Pluralsight, swag, and additional customized mentoring from Google and Google developer experts. The top 10 teams will also be invited to present their solution to Google and developers all over the world, live on YouTube during the 2021 Solution Challenge Demo Day. During Demo Day, the judges will watch the top 10 demos and interview the finalists. The final 3 winning teams will be announced live during the event, winning all the prizes included in the top 10 category, along with a Chromebook and a private meeting with a Google executive. The Google Developer Student Club Solution Challenge is a great opportunity to learn the latest Google technologies and kickstart your career by learning through doing. You'll be collaborating with Googlers and Google developer experts on your way to building a great solution. In the next video, we will explore the UN 17 Sustainable Development Goals and show you some ways to research and brainstorm solutions aligned with these goals. Thank you for watching, and I can't wait to see what you build. Hi, everyone. I'm Erica Hansen, and in this
Okay, as the video explained, you can go back to the Solution Challenge website and you can take a look at the video, and there are other resources listed there. As well as I highly recommend you read the rules of engagement, the rules, terms of services, what qualifies as a project, what doesn't qualify as a project, as well as the scoring rubric that we put together. That being said, I'm going to talk a little bit about as to what the 17 sustainability development goals are and why we selected this. Now, when we ran this in the past, students started building things that they thought it was useful, and there was no real guidance around it. There was no theme around it. We kept getting what you would usually build at a hackathon. Oh, there's a little bit of AI that can detect whether this is a plastic bottle or a paper cup, and then it'll tell you which bin to put in, which is kind of good. It's done so many times. Great exercise to do on a weekend, but it doesn't really solve a real problem. So to give more guidance and structure, we decided to pick the 17 sustainability goals. Now, this is nothing new. This has been done by so many other organizations throughout the globe. So I highly recommend going to the UN's website, taking a look at that, see what past projects that they've been working on, and maybe take a step back and think about what you're building and see what it would fall under. So for example, let's say you're working on an education space, see what that education initiatives outlined by the UN would look like. So for example, number 4, quality education. What does that mean? So for quality education, it can be something simple as maybe you want to improve the infrastructure. Maybe you want to, it's a video platform, and keep that in mind. The other thing I want to talk about is there are so many mentorship opportunities available. My greatest advice I can give you all is your peers are your greatest mentors. You won't realize that today. In a few more years, you'll get to realize what I mean by that. So, for example, don't be shy to bounce something off with your friends and not necessarily close friends. Sometimes they agree, so they don't want to hurt your feelings. Do talk to other members of your clubs. Do talk to students from other clubs. And if you, I think you have that pitch event today, which is going to be great to put it yourself out there, and then take all the feedback as constructive criticism. Don't take anything personally, and then see where it goes from there. The other advice I can give you is we are even created. I know Andre is running, helped us run like a Firebase series, and we have a Discord set up. And there's thousands of kids there who are asking questions and building things, and they have a lot of those resources available. So there's a huge pool of knowledge that you have access to. Not necessarily, you don't need to chase after a Google to get answers. And that's exactly what we wanted to build, because I work with engineers at Google who never use GitHub because they didn't have to, because we have our own internal tools. So I push our engineers to go outside and explore a little bit from time to time, and I can give you the same advice. You have all the resources available with you in your community, so make sure to tap into that as well. You want to jump on the next slide, Bobby? Okay, so I know Erica's video mentioned there are certain prizes. Now, in the past, we had this set up in such a way that the top 10 teams would come to Mountain View, and then they get to pitch to some of our executive teams, and there's going to be a whole internal event around that. Since COVID happened, we are not able to do that. But you can still watch the video from last year's. It's streamed on YouTube. You can find it easily. 10 projects that got presented. This year, we wanted to focus more on the journey that you get to it, and not necessarily the prizes. Yeah, we do have some good prizes coming out, but we want to, that's why we increased the number from 10 to 50, and we created a number of different layers to it. So for example, you will be able to present at a chapter level, at a city level, maybe a regional level, and then go to the global level. So there will be so many opportunities for you to present, get feedback, work on yourselves while doing it, and so on and so forth. So yeah, Official prizes will be announced, but that's like an outline that we have it here. So if any advice I can give you, please take a look at all the rules, ask questions, reach out to developers, student club lead. We have a Discord server set up for everything tech related. You can jump on that too if you have any questions, and somebody will be able to help answer and clarify any of those things. That being said, I think that's my last slide, Bobby. Oh, there you go. Okay, so online support mentorship. Yeah, Parthian is also available. If you want to join there, there's about 150 GDEs are available too, but we've been running certain sessions with our GDEs, and if you need any connections, and we've been working with the DSC leads and put the pressure on them, meaning tell Bobby, tell Dakshika, tell your DSC lead saying, hey, it would be nice to get one of these guys to come and do a talk about this. And they'll reach out to me, and then we can coordinate that. I think that's also a great way to get questions answered and get some more knowledge around it. Plus, our GDE portal is available for anybody. They can go look it up and then see what kind of work they've done in the past, what kind of open source project that they worked on. Everything is available for you. So take a look at that. And if you have the time, you're welcome to join this platform and ask questions and network as well. That being said, I'm happy to take any questions. Anything you want me to clarify, I'm happy to do that. I don't know how we're doing on time. I was meant to talk for 10 minutes, but I think we're good.
Yeah, I think we're good on time. You know, if people have questions, feel free to ask them now.
Put them on the chat or unmute and ask, yeah. No questions. Has everybody figured out what they want to build? Are they already working on it? No. Don't wait till the last minute. If you really want to get something done, get it started soon. It doesn't need to be pretty. It doesn't need to be perfect. Also, the other thing I want to tell you was, like, for example, like if you have a problem and if you can solve it using a Google form and a Google sheet and with a little bit of app script, do it and then see how it goes before you go jump and build an application on Flutter or even using Firebase. So yeah, so there are some ways to get around things. Make sure you understand the problem really well, define the problem really well, come up with a project plan, make sure you stick to the scope that you signed out for, and then go from there. Cool. All right.
Great. Thanks so much for coming on, Madhusha. Really appreciate hearing from you. So thanks again.
Anytime. Happy to join any other time if you guys have, if you want to have me.
Hey, we'll definitely be reaching out. So thanks again.
Bye-bye.
All right, now we have Kelvin. Kelvin, you want to introduce yourself and what you're about to cover?
Yeah, but before that, I think there's a question in the chat.
Oh, I'm not in a team. Would I be able to participate? That's a great question. So it depends on how your individual club is running it too. I know for University of Wisconsin-Madison, we have a separate sign-up sheet where we can pair people up onto teams if they don't have members. But if you're already part of a club and you have some way to communicate with other members, I'd recommend reaching out there. But it is required that you have 2 to 4 members per team for the solution challenge. So be sure to reach out to your club lead or your club core team and ask them. Every club has a slightly different procedure, but nonetheless, definitely apply for the solution challenge right away individually, just so that you get access to potential free Google Cloud credits. That's one of the criteria to get the Google Cloud credits. It's coming on a rolling basis. So if you sign up, check that you want to use Google Cloud, and then you might find some in your email. All right, back to you, Kelvin.
Okay. Yeah, my name is Kelvin. I am the PR coordinator of the DSC chapter here in UW Madison. And so what we're going to be doing now is we're going to be forming a team. So it's going to be formed randomly. And I want each team to submit a drawing of their dream vacation. So in Zoom, there's this feature where you can share your whiteboard. So you just click on share screen and then click on whiteboard, and you should be able to open up the whiteboard and people can annotate on the whiteboard. And yeah, so I don't know how many teams there are going to be. Bobby? Four teams?
Yeah, about 3 to 4, yeah.
Yeah. So each team would have around up to four members. And yeah, I think 5 minutes is a lot. So you all are going to be given 5 minutes to draw up something and then save that drawing and then upload it to the link there. I can post it actually on the chat. Yeah, so save the drawing, upload it to that drive, link in the chat, and we're all going to go back here to the main group afterwards and see what you guys have come up with. So.
All right, thanks for everybody who participated and joined your group. You know, if you have any issues with the breakout rooms, let us know in the chat and we can make some adjustments. You know, it's a little janky. If some people don't update Zoom, we can't have people choose their rooms. So we have to get a little creative with it, especially coming up in the next breakout. So just let us know and we'll fix it for you. Drawing is hard. Oh yeah, with the mouse, I'm sure. If you want, and if you'd rather, you know, just like take a picture and then upload it like of a piece of paper or hold it up to the screen for your teammates, feel free to do that. Because actually for the next, for the design sprint part, for the first part of it, you're gonna be needing to do a lot of drawing. So whether or not you wanna do that on like, you have an iPad or like a piece of paper, anything works. That being said, we're moving to the design sprint segment now. So my name's Bobby. I'll be going over some of the basics of the design sprint concept and resources, along with the first design sprint task that we're going to be doing is called Crazy Eights. I'm a DSC lead at the University of Wisconsin-Madison, and feel free to add me on LinkedIn. Dakshika, want to introduce yourself?
Yeah, hey everyone, my name is Dakshika and I'm the DSC lead for Texas A&M University. My LinkedIn is there as well in case you want to add me. I'll be covering up the rest of the design sprint process and we'll be going over 2 exercises, storyboarding and prototyping. So yeah, excited.
Awesome. So let's cover what the design sprint is and why we're doing it and what parts of it that we're doing. So the design sprint is a design thinking process that Google uses. It's actually created by Google Ventures, now known as GV, but it's usually a few day exercise, but you can narrow it down into about 2 hours if you really rush. That said, we're not going to be doing the whole thing because we're coming up with ideas for a product, but not the product itself. And we don't have time to interview people about their input on it. So we're going to be doing the fun parts that you can do in a small team today. That said, the design sprint is, you know, it's made to get weird. You're supposed to think creatively and quickly and not shut out ideas. That's unfortunately what, especially in working in a corporate culture, or, you know, a lot of the times that the way that we're brought up, thinking critically about an idea, you know, that's a good thing, especially when the idea is already formed. But when we're trying to generate new ideas, we don't want to put any limitations on them. Want to get creative. There's no such thing as a bad idea. So don't worry if your sketches look weird or if you don't think it's a great idea. It can be a launching pad to revise that idea and then come up with something better. So that said, we're going to be putting some time constraints on some of these exercises to make sure that you're thinking quickly and not too analytically. So don't be afraid if we bring you out of your groups, your breakout groups, and you're not done. That's kind of the point of this, is to rush it a little bit. Be sure to check out the link below. That'll bring you to the resources page for the design sprint and for the solution challenge in general, and it'll walk you through all the steps. Today, we're only going to be doing 3 exercises. The first one I'll be covering, and that's crazy 8s. But as you can see on the right-hand side, there's 6 different steps. So first, understanding. So what is the issue you're trying to solve for? Then defining. So figuring out which sort of metrics you're going to use to measure the success of that project. Then you go into sketching, which is like prototyping. Well, like prototyping, except you don't put in the time, the effort to make it look really nice, and it's just getting the ideas flowing. Then you decide which idea you want to go with, and then prototype it for real. So what is it going to look like, maybe on the UI UX side of things. And then from there, you validate it. So you bring it to people that are actually going to be using this product and get their input and then start this over again, usually from either the sketch or the decide point. So, if you realize a lot of users aren't able to find a certain button to get to a certain page, then you move that and you iterate it next time. You bring it back to your users and you get feedback in a sort of agile process. One thing, and this is really important to consider, is the judging criteria for projects for the solution challenge. This is something Madusha mentioned that you should go over, so good thing we're doing it here. The points for grading are broken down into 2 categories. There's impact and technology. So impact is worth 60 points, technology is worth 40 points. If you saw this last year, if you participated in the solution challenge last year, it'll look similar, but a little different. You can see it on the number 2 for impact is worth 20 points. There used to be a different category there, but we'll go through a few of these. There's some that don't apply for the ideation stage. Some of them only apply for when you have a physical product built or virtual product built, but right now we're just focusing on ideas. So we'll just stick to the main ones that apply to that. First of all, does the entry clearly establish the challenge focused in one or more of the 17 SDGs? So are you picking a problem provided by the UN, and are you focusing on that? You'll see this is kind of a reoccurring theme throughout the judging criteria, because this is how important it is for the success of your project. You have to make sure that what you create is solving a problem that is outlined by the UN that you said you were going to help solve. Next is, does a solution address the challenge identified by the team? So that goes along with the first one. 3 is there evidence of a next step? So from what you have in your idea, where do you plan on going with it? How can you scale? How can you make it better? What are different features you can add? And then 4 and 5 we'll skip for now, because those are more about testing. Then on the technology side of things, does the solution implement all the technical components needed to solve the challenge? So if you're able to solve what you said you were going to solve, you'll get the points for that. In terms of the ideation stage, think about what technology you would use. It doesn't all have to be Google technology. You just have to have one service provided by Google. The rest can be whatever you want. So don't feel confined in that way, but you do need to know what you're going to use and how you're going to use it, or at least have an idea of it. Next is, has the team clearly explained what Google technology they used, why they included guidance, and included guidance on how to run their code? So that explains itself. What Google tech are you using, why, and how? Last one, has the team made effective product and technical decisions for their solution? So, did you make the right choices? If you're using machine learning and it needed to be visual, but then you went with BigQuery and didn't incorporate any TensorFlow, that's something to consider. So stuff like that. Is the technology that you're using the right technology? Now, for the ideation stage that we're working on right now, don't be afraid to have wrong answers, or there's no such thing as a wrong answer too if you have a reason for it. We're just trying to get creative here. This is not for a final solution. This is to get the juices flowing. All right. This is I gotta say, this is probably my favorite exercise of a design sprint is Crazy Eights. So what I'm gonna need everybody to do is grab a piece of paper, or if you're able to draw on your screen, that works too. But we'll break you up into groups, and then we'll give you about 2 minutes as a group to decide what sustainable development goal of the 17 that you wanna focus on. Now, to find those, go ahead and open up the tab right now. You'll see the first link listed at the bottom, goo.gle/solution challenge. There will be a tab at the top that says UN 17 goals, I believe. Click on that, and that'll list all the 17 sustainable development goals. Then you'll be able to click on the different goals and see what they're about, but their names are pretty self-explanatory. So as a team, you can take 2 minutes, decide on one that you want to focus on. And then after that, you're going to take your piece of paper or your screen and cut it up into 8 sections, or fold it if you have a piece of paper. So fold your paper in half again, one more time. You'll have 8 sections, kind of look like a little phone screen maybe. And that's what you're going to use to draw your ideas on. So we'll set a timer for 8 minutes. So you'll have a total of 10 minutes, the 2 ideas to choose, and then the 8 minutes to draw. And then each person in your team is going to have their own sheet, and you're going to have to create an idea of a solution that you'll draw out either in words or pictures to solve for that problem. So your goal is to come up with 8 ideas in 8 minutes. Now, like I said, this isn't supposed to be a final draft. This is supposed to be very creative. Some of them will be pretty wacky. That's all right. But when the timer goes off, then you're done. So we'll bring you back into the groups. And if you want to look at those for later to work on your next ideas for prototyping, be sure to upload those to the folder that we provided you. Even if we pull you out of your groups, you can still upload them after that point. So we'll go ahead and break you back out into groups again and set a timer for 10 minutes. So anybody have any questions before we do that? I don't see any. If you do, just shoot a message back to the main room and we'll be happy to help you. All right, see y'all in 10 minutes. Hopefully you've got some good ideas to work with. Like I said, not perfect ideas, they're not supposed to be, but something to maybe use as a launching pad for something you might actually use for the solution challenge. So now back to Dakshika for the storyboard.
Yeah, awesome. So coming from the Crazy Eights exercise, hopefully you all have 8 ideas or 4 ideas per person ready by now. And Storyboard is going to be the next phase of the design sprint. So it's going to help you visualize the use cases of your product, or just your website or app, like whatever project you're thinking of working on. And it gives you a chance to step into the user's shoes and try to look at your project from their perspective. So when you actually start building your project, you want to make sure that you test your project incrementally. And the storyboard exercise that you're going to be doing now is really going to help you later on, because you already have these use cases ready. So you will be able to test your product and get accurate feedback. So now that you have your ideas ready, what you're going to be doing is you're going to be drawing the use cases for your project, right? So just imagine different features or functionalities that you want to implement in your project. Anything that comes to mind. It doesn't have to be like whatever you will be doing finally, just anything that you think right now is an important feature for your project. Just kind of jot them down in a corner. You can come up with like maybe 8 to 10 different features that you'd want to implement, and just pick 4 or 5 important ones, or the ones that you think that will be the major features of your project, and just kind of try to draw them out. So maybe like create different boxes and try to draw out each feature and try to have like a smooth transition between them. So there should be in a sequential order so that there's like a flow between the boxes, right? So maybe you can imagine like when when a person first opens up your app, what is the first thing that they're going to see? So that should be the first box, right? And then you can go over, maybe they go to like a different page or something. So that's going to be, so you can just imagine like different test cases and try to come up with them, different drawings for all of them. And it doesn't have to be perfect, like Bobby said in the last exercise as well. Like it's just kind of coming up with ideas right now. So once you do that, and once you have your test cases kind of drawn out, what you want to do, the next thing is that you want to figure out some of the test cases which might be hard to implement, right? So we gave an example earlier, right? So maybe you have a button on your website which takes you to a different page. And then when the user is at that page, they're like lost of like where to find information. Maybe everything is like cluttered, or you just have too many things going on. So just kind of try to imagine which features could be hard for you to implement or for the user to just kind of use, and try to come up with a solution to make the user experience as easy and as smooth as possible, right? So the storyboarding exercise will help you kind of identify those edge cases and just try to find solutions for them. So once you prepare your individual storyboards, so right now from the Crazy Eights exercise, hopefully each person in the team has like a bunch of ideas, right? And now what you're going to do is just pick one of those ideas, whichever one like you feel you're most passionate about or most interested in, and just kind of storyboard that idea. And based on like the number of people in the team, when you have all of your storyboards ready, what you're going to do is select one idea for the entire team to go forward with. So just kind of select one storyboard that you're going to go forward with, and that's what we're going to use in the next exercise, which will be prototyping. So I think we're going to send people out to breakout rooms for 20 minutes, and you're going to draw out your storyboard and then also decide one kind of final project to go forward with to the next step.
All right, so we just finished prototyping. Thanks everybody for participating. Now, since we don't have too many groups left, too many people left, we're gonna open up the floor on the main stage for each team to pitch their idea. So you can all work together, or if you have one person that maybe wants to speak up for everybody and explain the idea, but try to keep it to like 2 minutes or less. And then we'll open up the floor for everybody to give ideas and make sure to keep out the criticism. We don't want anything negative. It's all positive, constructive feedback. So is there anybody that wants to pitch their idea first? Hey, Andrea, I know you and Swati were working on an idea. Do you mind? Could one of you talk about it?
Yeah, sure. I can speak up for it unless Swati wants to go ahead. Yeah.
You can.
Sorry, what was that? I didn't get that.
You can go ahead.
Okay. Okay, we didn't figure out the whiteboard situation, so I was just drawing on my little paper here. Just give me a second because I want to see what I'm gonna be presenting. Okay, so hopefully you can kind of see this. This is gonna be awful, I know, but hopefully you can see something. So the idea, we picked the, I keep forgetting the name of the sustainability goal. Quality education. Yeah, thank you. So what we came up with is basically this solution for a student portal, because basically the problem that we were trying to solve is that students are using other resources to kind of combine with the student portal instead of all the resources being there for you, right? So we came up with this idea of kind of viewing the timeline of your course in an easier way. So you can see that there is like a graph tree of different topics that are going to be covered in your course with different like timestamps for each one. And then you can see that it kind of branches off into other topics that are not covered in this specific course, but this is like next steps you can go to. So if you select this topic, you're going to go to a specific page that's going to give you some resources to learn from that, right? Like it's either the school programs that are related to that, like let's say you're using like learning React and you want to go into web development. Maybe there is a web development program at your school or university that deals with that, and you want to kind of switch to that or go to that program afterwards. And also like some useful courses that you want to learn as well. And then if you actually select the topic that is on the timeline, you go to kind of the course or that lesson page. You will be able to see the recording of that lesson, as well as some like in-class and assignments that are due at that day. And also something Swati came up with is also like this chat room feature, because a lot of the time you don't want to kind of use Zoom or Slack or Discord for that other tool. Want everything to be integrated in this one platform, so students can easily kind of talk to each other and maybe even talk with their teachers and share ideas about the topics and courses. So yeah, that was our idea. Swati, if you want to add anything else, feel free.
Yeah, that's an awesome idea. Thanks for sharing. Does anybody, mentor, participant, anyone want to share maybe one thing that you liked and one thing that you might change? So open up the floor to everybody.
For me, I really like the timeline idea. I think it helps like visualize and put things into perspective of where you stand, like in accordance to the progress. And I just had one question: is this timeline for like every semester or like throughout your like college, on where you are regarding like your major credits and stuff?
It's actually a very good question. We didn't think about it that way, but it could be any scale, right? Like we were thinking about course-wise, right? Like if you have a specific course, then you would tackle topics based on what lessons are kind of covered in that course. But you're right, it could expand to like your whole like education kind of path, right? Could be that.
Yeah, it's really great. I really like this. Pretty unique too, I guess. Haven't like seen it before.
Awesome. Who else has some input? I just want to say, I liked how when you drew out the UI, well, it kind of showed the UX and how with the arrows people would interact with it. And I liked how it was like a one single platform to do all these things on. One thing I might wonder is like, how could this be like, instead of like, I guess this is more of a question. Is this more for like major institutions, or is this for anybody, looking at like a educational supplement sort of?
Yeah, I mean, Swati, if you want to kind of speak up to that, I don't want to steal all the talking from you, but in my opinion, I was thinking about like just my college, for example, right? Like because our student portal is meh, like at best, it could be better, right? But yeah, Swati, do you have any other ideas in that regard?
Yeah, I was also thinking of it being only for the students who have registered for that university, because we'll be suggesting other courses also based on their interests, and it might be more appropriate to have the students in that university.
Yeah, so that's the main focus, I guess. But
I love that. And I love like what you're saying, Swati, and how it kind of like expands it a little more too. I think that'll help, really get points from like the affecting, the SDG, the Sustainable Development Goal. So cool. Anybody else?
I had one question. Yeah, so my question is this like a one-stop solution for, so like you said, if it's for college, right? So would it like be like a replacement for the system that you use already? So what I mean is, will there be lecture recordings, notes, files, everything would be stored on this platform, or would this just be like a tracking mechanism, and to view the actual lectures, you'll just provide links to the system you use for college?
I like your questions because it actually could be both, right? Like it could be either a replacement or it could be an extension of an existing system. Like I can see this as like a Chrome extension, for example, right? Like it literally like scrapes your course information from your portal and then like draws a graph for you where you can like go and explore other topics. I mean, yeah, that's like some great ideas. Why do you have any input on that as well?
I think after hearing your feedback, I think it might be like good to have it as an extension, because I don't know if most universities will be willing to adapt. So scraping and having it as an extension would be a good addition.
Yeah, that's actually a great idea, I think.
Yeah, exactly. Like even with the like replacing thing, the technical complexities would increase like tenfold or exponentially. So
yeah, thanks for the question.
I might want to present. So to focus on the impact first and the technology will follow. So if you can see my screen, usually if you have your vision focused first, finding the technology is the easy part, because either you already know it, already know how, or you're already connected to a DSC who has connections with all of these different technologies. So even if one of your peers doesn't know, the other club members don't know, your core team or even your DSC lead doesn't know, you can reach out to the huge group of people, all the GDEs, the Google Developer Experts on Parthenon, or to other DSC clubs. So you've got a huge network of people at your disposal to work with and bounce ideas off of. So please, please, please don't lose that opportunity. Like while you're a part of DSC, use this to build connections, to build networks that'll help follow you outside of this program. That said, if group 2 doesn't want to present, we'll keep moving on. And study jams. So now we're going to open it up for our study jam topics. This will give you a really surface level introduction to some of the technologies you can use to help make these ideas. For our first session, so you'll be able to pick between two. In order to pick, since we can't let people choose their own rooms, we changed everybody to be able to edit their name. So first we have Andre with Firebase, and I'll let each person introduce their topic a little bit here on this page, and then Chloe with Flutter, but we'll call Andre number 1 and Chloe number 2. If you want to learn about Firebase, change your name and put a number 1 in front of it. If you want to learn about Flutter, change your name and put a number 2 in front of it, so we know how to put people into groups. That being said, Andre, Chloe, you guys want to introduce yourselves?
Yeah, for sure. Hi, everyone. My name is Andre. I'm a DSC lead at Conestoga College in Waterloo, Canada. And I'm going to be covering Firebase, which is kind of your backend as a service tool, which I think, honestly, like if you're building a prototype or like a solution, anybody should use. And Chloe going to speak up that it integrates very well with Flutter as well, right? So yeah, I'll be starting with like some React application, which you're also going to be learning how to build later on today. And then I'm going to be adding Firebase and looking how that all works and how you can implement things like auth and storing some data elsewhere. So yeah, join me if you want to learn about that.
Thanks. So yeah, similarly, I'll be teaching about Flutter. Basically, you would use it to create more of the front end of your mobile or web application. I'll just be giving a brief like introduction and sharing a bunch of resources around learning that. And then as well, yeah, definitely I will be talking about how like it does relate to Firebase and you can use it as your backend for next steps. So yeah, feel free to join that if you have any questions around development for Flutter.
Cool, thanks guys for sharing. And I notice right now people don't have numbers in front of their names. If that's the case, I'm just going to put you into random groups. But once I see the numbers pop up, then I'll move you to the right group if you want to be in the other one. So as of now, I'm just going to put you into random ones. If I see your numbers change, I'll put you in the according ones. So just give me a second.
One question. How much time do we have again? Like half an hour is the...
Yeah, half an hour. If you want to be done before then, just send a message to the main group and we'll bring it back.
I'm just afraid that I'm going to be over, but that's fine. Half an hour is fine.
Sounds good. I know it's a lot. It's a short period of time to introduce big topics, but you know, this is like just dipping our toes in.
Very good, Robert.
Hey, how's it going?
Yeah, okay. I'm assuming we're good. Okay, I'll just start anyways. But hello, welcome again. I am Chloe. I'm the DSC lead at the University of Toronto in Canada. And I'll be talking about Flutter. It's just a quick introduction, some resources. Personally, I use Flutter for kind of like a part-time position. Currently developing a mobile app for UNICEF. So that's kind of what I'm doing with Flutter. So hopefully what I'm sharing today is actually kind of useful for maybe any future opportunities as well. But yeah, so kind of some introduction. What is Flutter? So Flutter is made by Google. It is all open source, which is great because it is very budget friendly. It's a complete SDK for just building apps. So this is including both mobile and web apps. And it's mostly focused for UI, so it's a very front-end focused, but you can definitely add a back-end later on. And you can do this to develop Android, iOS, Linux, Mac, Windows, and Google Fuchsia, all in one code base, which is great. And the language used is Dart, so it's usually more of like a just-in-time execution kind of engine. So once you're like developing and debugging, it's updated in real time, which is like super great. It's super fast. And yeah. So what is Dart? It is one of those main things that was built on C++. So it's super fast. I think I love that because of it. And it offers a very productive programming language for multi-platform development. So it has like flexible runtime and it is great with different app frameworks. So it's more designed for kind of quote unquote a technical envelope, and it's suited for client development, prioritizing both development for hot reload. So I'll talk more about hot reload next. And it's great for high quality production experiences. So I found that it's very great, and it's great like for fast applications as well. So if you are ever worried about how fast your mobile or web app may be, Flutter's a good starter to go towards. And yeah, next. So why use Flutter? So some of the use cases that you might come up with, or maybe you might debate with when you're deciding to use Flutter, is that one of the best parts about it is that you can just write code once and you can apply to all platforms with some minor changes, but you'll slowly learn what those minor changes are if you're going really hardcore into Flutter. And things are also still in development for Flutter. So since it is made by Google, they're constantly evolving it and constantly fixing it. They're noticing lots of bugs, but they're always trying to work to fix that. And it's also great because companies use it a lot because they have a limited time or budget. So especially a lot of startups or early ventures, they try to use Flutter as much as they can. Maybe they want more apps for the price of one, which is why it's great because it's open source. And it's also because a lot of old native apps cost too much to build and maintain. Sometimes they would have an old project on like Xamarin, for example, but maybe they're looking for more cheaper options. So this is why they would transition over to Flutter. And of course, there's always the high speed of like the C++ core for Flutter, something around like 60 to 120 FPS in animations. So like if you're like a techie like me, you probably know what that means, but like it's just really good and fast. And Google actually uses Flutter as well for their own applications. So they use it for Google Ad Assistance and Stadia apps. So it's becoming a lot more popular in big tech companies. We just have to give it some more time. So one of the biggest news that came out around Flutter as well is that there's Flutter 2.0. So initially it was all just on Flutter 1.0, and that was the most stable version of Flutter. But recently they came out with a lot more features. So a lot is like the web support. When you're developing a web application, they now have SDKs for mobile ads. So if you wanted to add an ad to your app, like there's the option. And also a lot more features and widgets that you can play around with. The example I have above is just their like website example. And you can test out your Flutter code through that. And it's still in development, but it's also, you can try it out as well. So it's cool, super cool. You actually don't really need like the whole setup to try out Flutter. So yeah, now I'm gonna start getting into the whole development process of Flutter and how you get started in it. So mainly the tools you'll need is either a Android Studio or Visual Studio Code, whichever the one you kind of choose. Personally, for me, I love Android Studio Code for Flutter development, but I still use VS Code for other development. So it's all based on personal preference. And then from there, you would download the Flutter SDK, which is on the Flutter website, or you can also, the Flutter SDK is on their website, and you can also get redirected when you try to download Flutter as plugins on your different code editors. And then lastly, you need a physical device or an emulator. So personally for me, I'm not using my own physical device to test out my code, just because I don't trust myself to sacrifice a physical device. But you can also use an emulator and just download either an Android or iOS. I know for if you have a MacBook, you can only download an iOS emulator there, but if you want to do Android, then that's super free as well. So getting started would be to set up your environment. So I'll share all these slides after, so don't feel free to like not have to like worry about all the links right now, but download the Flutter SDK, and this is all based on instructions on your operating system, and then choose your editor. So of course you just either Android Studio or Visual Studio Code, and from there on your Gucci. So one of the best things to start with when you're learning to use Flutter is definitely the whole hello world kind of code when you're just getting into your first language. There is a great tutorial for your first Flutter app that is on Code Labs. And it's just basically a step-by-step tutorial to get the following app. It's like a startup name generator. So as you scroll, you'll learn all like how to generate new names constantly. So it's great to learn about different things like implementing stateful widgets and also just the whole infinite scrolling of an app, because who knows, you might need it. And then from there you would do part 2, and that's when you add more of like the features of an iOS app, and also add a lot more pages to your app. So yeah. So those are just some examples of us starting, but I'll get more into detail around these different features. So one of the biggest features that a lot of people forget about is the hot reload feature of Flutter. This is just a great way to constantly save and test out your app. So as you're saving, it updates in real time, which is like the best part about it. There's this great article that shows like how to set it up, because kind of the Flutter documentation might not be so clear. So I added that as well, but all you have to do is like as you're coding, you would just Control-S when you're saving your files and it will just update in real time. So that's just the example shown there. But yeah, by the end of setting up your whole environment, your space would kind of look like this. So usually you would have your code on one side and then the emulator on one side, and just seeing it constantly updating. And this setup kind of depends on how long it takes for you to set up, but I found like my slow computer does not like my emulator that much. But that's completely up to you, who knows. But yeah, that's basically the setup. So now I'm just gonna start talking about like the user interface and working on the front end of your mobile app. Kind of the things I'll cover is like the layouts and then the type of widgets you'll see and then navigation options. So these three main things are probably the most used widgets you're actually going to use as well. So it's really good to know these. And then once you have these basics down, it's really easy to just build on top of that with extra features. So to start, layouts. So with if you've worked with object-oriented code before, this might seem familiar, but if you have not, then this like tree diagram is like the perfect way to describe it. But basically everything is built on this whole core of widgets. So you'll see like in the Venn diagram, there's like containers. Underneath each container, you have like different widgets. So everything's like inside of each other. So just think of it like those like, I guess those like the like recursive code, but I don't want to say recursive because that's just like that's traumatic itself to think about recursive stuff. But those like dolls where like if you constantly open it up and there's like more dolls inside and it just gets smaller and smaller. Eventually you'll get to like one doll inside of it. It's kind of similar to that. Everything's inside of each other. And that's how Flutter's code is kind of created. But yeah, I'll get more into detail about that later. But you'll notice how container is like one big overarching thing. And then around this box is that container. Then as you get in, you'll notice that there's smaller containers. So there's three. So specifically, there's three containers for the call, root, and share icons. And then from there, you'll see there's the icon option and then another container that shows the text. So you'll see that it like over encompasses like all the different features of the widgets in Flutter. So next, you would be selecting the layout widget. So this is how you want to align or constrain the certain widget you have. So there's single widgets where you're only allowed to align maybe one certain widget, or there's multiple widgets. So this is where you would put multiple widgets underneath it. In the example I gave previously, this is more of a multiple widget type of layout. Specifically, it's the row layout. So let me show it here. But yeah, rows. So this would be a list of child widgets in like a horizontal direction. So that's like an example of using that. But if you just want to align things like maybe in the center, like it's one button, then you would just use the center widget. These images are great. They're all on the Flutter documentation and they show it. So if you're ever looking for what type of like item you're looking for on a screen, then you just refer back to the different layout widgets that Flutter has. And they can just show you a step-by-step. Yeah, these are the most common ones used. These are the ones I've mostly noticed I've used a lot. So column, grid view, row, center, and align. So once you have your visible like layout set, then you would pick a visible widget. So that would be either something like text or image or icons. So these are things you can actually see on your screen. Yeah, you could tell I did this last minute. But yeah, this would be kind of the example of creating different widgets that are visible on your own app. Then you add those two together. So this example is done with a center layout with a text widget. So you can see that the center is kind of in like covering that text widget inside. And all you'll see for this is just the word hello world in the middle of your screen. So that's just an example of putting two of those things together to create something visible on your screen and is aligned to what you want it to be. And then that's how it would look. So it's not the prettiest app, yeah, but you got your Hello World app there. And the full code is all on the Flutter GitHub as well. So you can always refer back to it if you need like a starter code for your Flutter app. And you can always just like copy that over to your code and just use that and then build off of that app. But yeah, that's how you get a center text. So there's a lot more layout widgets that I did not cover. Those are just the main ones. Things like laying out stuff in the row or column. So that's like an example here of like the tree for that. and then adding items in a grid. So imagine you want to do something like an Instagram feed, then you would do something like a grid. And then as well, there's list items. So if you're trying to do something like a settings page, then you would use a list layout. And then last is the stacking. So if you want to do profiles with their names and stuff, then you would use the layout of stacking. So something to note as well, there's two types of widgets. So there's stateless and there's stateful. Kind of the broad definition is that stateless is immutable. So those cannot be altered once you run the app as well. So this is an example of doing things like pictures, like you don't want pictures to change unless you do want pictures to change. Sometimes it's icons and buttons. So maybe your icon and button, you don't want to change that as the app is running. Versus stateful would be mutables. So these are things like variables where maybe you want to change the language of text. So you want something more immutable that you can change constantly in real time. So that would be an example of what you would use a stateful widget for. These are just the example code of having a screen that's either stateless or stateful. And yeah, it looks complicated at first, but you'll realize it's just copy and paste. You find a lot of the templates of everything and you just like copy it over to create your app. And it's pretty cool like that because there's a lot of documentation around all the different ways to build these different apps. And then another thing I'm going to talk about is navigation. So what I love about Flutter's documentation is that they have this whole thing called a cookbook. And it's just all the recipes, quote unquote, that just solves all the problems you have when making a Flutter app. So it's like what I said, you copy and paste over the code and it's all done for you because they're all like quote unquote recipes. And once you get used to it, you start to realize that you can just copy a bunch of code over from their cookbooks and you can build a full-fledged app out of that. So some examples or two main navigation pages that I'll talk about is one when you're animating a widget across the screen. So maybe you want like an icon to move from one side to the other. I don't know, maybe that's what you want to do. Then that's the common navigation. And then another one is if you want to go to a new screen. So if you're building multiple screens, you probably want to use that type of navigation. So yeah, if you want to go to a new screen and back, usually pages are called routes in Flutter. So a route is known as a widget as well. So you just create two routes. So it's like two endpoints. To go to the second route, you say push for navigator. And then once you're on that second route, you just say pop and you just go back. So you just go back and forth with pop and push. So here's an example. So this is you at your first route. So all this code is all like the copy and paste of a general stateless widget. But in this here, you'll notice that we have the center and then a button and then text. So that text is open route. So that's the example here. And then when you press it, it's navigator push. So you're trying to go somewhere to another screen. So in this sense, we're going a second route. But yeah, that's just an example. And this is what it would look like. You would just have a button on your screen and it just says open route. And then once you press it, you go to another screen. And that would just be another center button that's pressed and you would do navigator pop. So you're just going to be going back. And the text on top of it is just go back and it'll look like that. So you keep pressing both buttons back and forth and you're still just going to be going back and forth from different pages. So yeah, that's the most simplest way to do back and forth navigation between screens. Another one is the animate a widget across screens. So you would use something called a hero widget. If you've heard of like hero banners in the past, then it might seem familiar, but basically it's just more of like transitions across the screen from one place to another. So similarly with the navigation of screens, you add the hero widget to screen 1 and the hero widget to screen 2. So then it's like doing like a cut paste of like where do you want the animation to start and where do you want it to end. So an example of this is your hero widget would go to an image here. So of course, just image, network, and then the link of your image in your files. And then you encompass it with a hero widget. And then similarly with the second thing, with the second screen, you just do same thing, but this time I put it in the center of the screen. So initially it'll just go from one position to the center of the screen, and that's the animation. It's the most boring animation, I'm so sorry, but it's a great example to show that you can do animations across the screen. And this time it's the same thing, just hero, same tags, the image text, and this time we just use center to show that it's moving to the center. So now I'll be talking about next steps. This is super broad, just because, especially in the solution challenge, you're not really focusing on the back end per se, unless it is like a big part of your solution, but I'll just broadly cover it for Flutter. So one of the biggest things you have to consider when you're making a backend is something called state management. So this is where you save different states of your app. So an example they gave was a shopping app. So you want to save the items that you have, but you also want to save the account information you have. So you wouldn't have multiple screens to save all the different types of logins or different types of accounts that exist. You just use something called state management, and that's just different states of one screen. So maybe my account has one state, Robert's account has another state, you know, like we all have different states of one screen, and you don't have to develop each screen. So that's what you would call state management. And the source is there to read more about state management. And then one of the biggest backends you can use is definitely Firebase. So they actually have a whole plugin for Firebase in Flutter that you just download and just copy and paste code. And they have a whole guide as well called the Flutter Fire. It's just basically they're like together documentation, and you just read through that to set up Firebase for your Flutter app. But yeah, that's basically adding a backend. That's the most broad definition, but those are just good resources to hit up. Some conclusion items. So the tutorial series, there's a huge workshop recording of Flutter development, both beginner and intermediate. Definitely recommend it. It was done by a different DSC lead. I forgot the name, Rohan. Yeah, Rohan. But yeah, the links are there as well to watch them. I know what he does. He builds a new app every workshop. So if you just want to look at one specific app and follow along with that, that's a great resource as well. And then a lot of other resources I linked here that you can also check out. So things like documentation, tutorials like code labs. So one video series that I always recommend is the Flutter tutorial by the Net Ninja. I used that when I was learning Flutter, and it was a great tutorial. Free Code Camp has one as well. And there's also an upcoming 5-part Flutter workshop that's by another DSC in the area. So yeah, sharing some links as well if you want to join our DSC chapter at UTSG. And then besides that, that was all that I had. If you have any questions, let me know. I'll be here. Yeah.
Oh, Chloe, I accidentally sent you a message instead of Dakshika, so sorry about that.
No worries. But yeah, if you have any questions, they're there. To view these slides, let me put it in the chat as well. So this is a link to view the slides. So if you also want to use that as future reference, feel free to. Yeah. Yeah, besides that, that was all I had. If you have any questions, feel free to like message me or unmute, and I'll be happy to answer them. I'll try to answer as much Flutter questions I can because I mostly know front end. So if you need back end, probably Andre is the best person to hit up for that. But yeah.
Chloe, have you used React before? Are you familiar with React?
Yeah. Yeah.
Or just like kind of like what are the differences between the two, and why do you like Flutter versus why do you like React for different reasons?
Yeah, so React I've noticed was built more for web, or I found it more easier to build for web, but Flutter was built like mobile first. So it was always built for the intent that it was just going to be for the mobile, and then now they have it expanded so that it's for the web as well. So I just love Flutter for mobile development personally, and that's like my preference. But if I'm using like web, then like it's definitely like a React or Node framework type of vibe, just because it's built for web first. Yeah.
Cool, thanks.
Does anyone else have any questions? We're vibing. We're fine.
I've got another one, I guess. So for people who are wanting to find those videos, what's the name of the YouTube channel they can go to find those?
Great question, Robert. It's Think Outside the Valley. Think Outside. Let me put it in the chat. I can't even spell it. I'm sorry. Outside the Valley.
Is and also different kind of services that Firebase has under its hood. So I'm going to be touching 4 services, which is authentication, Firestore, cloud functions, and actually hosting your website with Firebase hosting. Then any questions that you have, you can ask them. Once again, if you want to ask them during the session, just unmute yourself and feel free to do that. So yeah, Firebase is basically, oh wow, this is actually interactive. I was not expecting this, but it has kind of a set of services in it, which basically divides into 3 main groups. The first one is when you build your app, you want to kind of use authentication or like data storage or storing some files somewhere to improve the functionality of the app. There's also some machine learning functionality. There's a lot of things. Then there's also kind of the quality pillar where you already build your solution, you want to test it, see what works, see what doesn't. And then there's the growth pillar when you already have your user base, you want to explore what your users do, different patterns in that. So analytics is a huge one. You can perform some A/B testing. Obviously, I won't be covering everything, but that's like all the things you get from just using a Firebase project, right? So that's, oh wow, okay, that's going to be interesting. Yeah, that's what I'm going to be covering. So only 4 of these, only the first 4 services. I'm going to be focusing on auth, cloud functions, cloud Firestore, and hosting. All right, so actually, before I jump into Firebase Auth, I'm going to show what I'm going to be building on. So hopefully you can see my screen pretty well. This is a very simple React application. So I'm just going to quickly go through the code and explain what it is. So you can see that there is just one component that's going to be rendered. I'm very sorry if anybody like saw 0 React code before, but I'm going to try and make it as simple as possible. So on the front end, what it looks like is actually something like this. So what we're going to be building today is like a chat application. So what you can do is like, I don't know, add some messages. If you're not authenticated, it's going to be just labeled as someone. But if you're going to log in, for now, it's just a fake kind of user 3000. I do not know what to put there. But if I type something here, you will see that my message is going to appear on the right. Everybody else's message is going to appear on the left. You can log out, log in, that all works. The problem with this app right now is that if I reload the page, all the messages will be gone. So all the messages right now are stored in memory versus kind of a backend backing that up, right? So that's what we want to fix. Just a quick overview of what's happening in the app and how it looks like. So we have our app component that basically renders the form, which is this input and a button, and also a bunch of messages in a list. So it is using like a bunch of services so there's actually 2 main ones: the message service that listens for messages and executes some callback when a new message comes in, right? And then you can also send a message when you hit that button. So I don't want to go into code too much, but those like a high level things that you can do. And then there's also the authentication service. which allows you to do three things. You can listen when the authentication state changes. When you want to log in with Google, that's something we will implement today, and also log out. So yeah, that's like 5-ish different functionalities that we want to implement with Firebase. So I'm gonna go like straight up. I want to go to Firebase. I don't have anything set up. I will click on Add Project, and I will call this something like React Fire. Let's enable analytics, because why not? Add an account for the analytics. And it's going to create our project. So what is this doing? This is creating like a cloud instance. Like basically, it's very similar to Google Cloud. Actually, this will create a Google Cloud project for you. And it will enable a bunch of services that we will be looking at. And actually, the first one that we'll be looking at is Firebase Auth. So Firebase Auth allows you to use different providers to authenticate, or actually implement your passwords and email and password authentication system. Tons of functionality there. If you ever saw like login with Google or login with Facebook, that's what this does. Let's see how easy it is going to be to set up. Before we jump into Auth, we need to kind of connect our app to Firebase first. So we can see that our project is created. And here's how it looks like. So you can see that there's these three kind of sections: build, release and monitor, and engage. So quite similar what I've shown you before. What we want to do first thing is to go to our project overview and include an app to our project. So I'm going to include a web app. I'm going to call it React. Yeah, sure, I want Firebase hosting enabled for my app. I'm going to register it. Let it run for a couple of seconds. So these are the CDNs that you want to include if you're building like a static website. We're building a React application, so we will actually need to install Firebase, and I'm going to show how that's done. I already have Firebase CLI, but what this does, it just allows you to run some Firebase commands in the console. And finally, these are kind of the steps how you would deploy your website. So I'm not going to follow that through just now, but you can see that this added a new web app to my application. So the first step that I want to do is I want to add Firebase to my project. So I'm going to install the npm package of the Firebase. Yarn add Firebase. So that's going to run and install some dependencies for me. Then while that's running, I'm going to go to my web app and grab the configuration for it. So here you can see that my web app has a lot of things associated with it, like CDNs that we saw before. That the configuration is what actually connects your front end to your Firebase. So I'm going to grab the config, and I'm going to go to where my app is being initialized, which is the index JSX file. So you can see that if anybody ever wrote React before, here's where my app is being kind of bootstrapped. That's the entry point of my whole system. So I'm going to just dump it here. We can see that Firebase successfully installed. So I'm going to import Firebase from Firebase. And what you want to do is you want to say Firebase.initialize app Firebase config. And what this is going to do, it's going to kind of connect your front end to your actual project. So you can see that there is some API keys, auth domain. I'm going to talk, I don't want to talk much about this, but I'm just going to say that it's for Firebase, it's safe to include these in your source control, even though this is like sensitive information. I'm not afraid to share this because only authenticated users will be able to talk to my application. So cool, we have this implemented. And now what I want to do is I want to run Firebase Init. So Firebase Init is going to enable a bunch of services for me. Actually, before I do that, I want to go through and in my console also enable those services. So we're going to be covering authentication, which I can just say get started. This is going to include authentication to my app. And I want Google Auth. So I'm going to say enable. That's going to be the support email. And here we go. That's as easy as it gets. You can just include Google to your console. So yeah, the idea is that you don't want to, like, if you're not using some services, don't include them. If you want to use Google Auth, just check that one. Don't check all of them if you don't want to, right? Like you're only going to be using kind of the services you want. Yeah, so that's actually everything we need. Maybe I'm also going to walk through hosting. So that's going to also, once again, give me some different steps that I want to include. Firebase Login, something you would need to run the first time you ever set up Firebase. I'm already logged in my CLI. In fact, I'm going to quickly do that. So if I do Firebase Login, it's going to take some time, but it says that I'm already logged in as my user. So yeah, let's just click through this. Nothing too exciting yet. And it's going to say that it's actually going to create a real link to my website, but nothing too excited yet. There is no deploy, so this will just lead to nothingness. It's just going to say that site is not found. But by the end of the workshop, hopefully we will have a working app on this website. So yeah, let's run Firebase Init. Hopefully you can see my terminal well. So this will ask me what things do I want to enable from the bed. Right now, I just want hosting. I don't care too much. Authentication is not an option. That's what you enable through the Firebase console. But yeah, that's all I want to select as of now. I will be able to like add different services as I go. Let's press enter. I'm going to use an existing project, and I'm going to use React Fire. My public directory is where, it's not this public directory, don't be confused. It's actually where your app is going to be built to. So it's the build directory for React for my setup right now. So I'm going to specify build. Yes, you can rewrite my index.html. I don't want to set up GitHub deploys yet, although this is a very useful feature. Yes, let's override this, and that's pretty much done. We have initialized our project. Everything is connected. Everything should work fine. Finally, let's look into how to set up auth and how that's going to work. So I'm going to go to my auth service. And right now, this is just a bunch of fake stuff. For example, you can see that here we are logging in with some random user, which means nothing, right? On auth stage changed is the Firebase way of listening for changes when you log in, like log out. So what I'm going to do in all the cases, I want to import Firebase from Firebase, and I want to use Firebase Auth in this case. And this is how you call different services within code. So Firebase Auth, and then I can say on auth state changed. And what this means is that this callback, which I'm passing to this function will be called whenever I log in or log out, and also on the page load. So whenever my state as a user changes, I want to kind of do some stuff in my app. So how would we log in with Google? There's actually a function for that. It's very, very simple. You can do Firebase Auth, and you can say sign in. There is two options, either with a pop-up or with a redirect. I'm going to use redirect in this case, but pop-up is also a valid option. It's basically UI-wise how the provider will be displayed to you. So if I sign in with redirect, I see that I need to give it like some provider, because Firebase needs to understand, does it need to like authenticate with Google or with Facebook or with whatever service you want to use. So I'm going to do provider, and I'm going to define it on the line before that. So the provider is actually Firebase Auth, Google Auth provider. That's what I want to use, and I want to new it up. So I want an instance of that provider, and that's what I'm going to put into this function. So just 2 lines of code to authenticate with Google. I think that's pretty awesome. you want to ask, like, how do you log out with your auth system? Well, there's a method for it. Firebase Auth and sign out. That's all you need to do. As simple as that. So let's actually rebuild everything and check out our application and see how it's doing. So I'm going to refresh this. We don't see any errors. That's a good sign. I'm going to log in. It's going to take me to another page, which I can choose my account, which Google account I want to log in with. If I choose my main account, ooh, yeah, okay. For a second, I thought it didn't work, but here you can see that my name is displayed correctly. I can log out from that account. In fact, if I type a new message, you can see that my name is also being used here. And this is just how the app works right now, nothing new, but we just connected auth. We can just connect and like log in with Google Authentication in 10 minutes, right? Let's not stop there. Let's move on to the next service that we're going to be covering, and that is Cloud Firestore. Cloud Firestore is amazing. It's a NoSQL database, which it's a very, very simple way of storing your data in the cloud. There's this kind of, if you're familiar with SQL databases, this is going to be very new and unusual, but you have this structure of kind of collections and documents where you store documents in some collections. What our structure is going to look like is we're going to have like just one collection of messages, and there is all we want to do is just store all of our messages in one place. So yeah, let's just see how that's done. There's some features to it, like if you want to read in depth about Cloud Firestore, and actually any service at all, go to Firebase Docs. There's an extensive guides and also video tutorials. Me and also Raf done a great series about Firebase. I'm going to link to that at the end of the session. But today I'm just showing like hands-on what it looks like in code. If you want to explore more, kind of jump to other resources, I'm going to point you where the next steps might be. Okay, let's not waste any time. So what I want to do is I want to enable Firestore on my console first. So I'm going to go back to my console and select Cloud Firestore. This is going to give me some resources straight away. I'm just going to create a database. I want to start in test mode so everybody can read from my database. This is like Firebase Firestore rules, which define what you can do with your database straight away. I need to select where my database will be hosted. There's a bunch of locations you can select from. I'm just going to leave it as default. And yeah, it's going to create a database for us. While this is running, I'm going to prepare the command that I need to run in my console. I want to also initialize Firestore in my development environment. So I want to run Firebase Init. Again, like if you just run that, it's going to take you through the same steps we already went through, but I just want to enable Firestore. So that's what I'm going to do. Firestore. Let's check on our database. Here it is. It's all great. I'm not going to create any collections at this point. I'm going to do that from code and show you how that's going to happen. Yeah, let's do Firebase Init Firestore. It's going to take me through some setup. It's asking me about what files to use for different configuration options. I'm just going to click through the default ones. Yeah, that's fine as well. Cool. Firebase initialization complete. So I have this, I have this weird thing, which I kind of want to store messages in. So how do I actually do that from code? Let's go to our message service and look at how we can implement that. So our message service right now does two things. It listens for messages or updates to messages, so it can re-render our list of UI messages. And it also can send a new message to our database. And everything is happening in memory right now, right? Like, as you've seen, if I refresh the page, all the messages will be gone. We want to fix that. So first of all, what I want to do, I don't want to do that. I want to create a collection in my Firestore and listen to any updates that are happening in that collection. So similar to auth, I'm going to say, let me first import Firebase. Import Firebase from Firebase. And then I'm going to say Firebase Firestore. And I can create a collection straight from here. I can specify that I want the messages collection. And there's an amazing method that is on snapshot, which allows you to listen to any updates to that collection. This is some like complex concepts, to be honest. Like I didn't want to go into it in depth in just 30 minutes. I want to show you how you would write some code to make it happen with Firebase, so you have some idea of how that's implemented. So on a higher level, this will just notify me of any updates in my collection. So I want to get the snapshot. And what do I want to do with that snapshot? The snapshot is the snapshot of my collection. So first of all, I want to extract the messages from that snapshot. So I can say that the messages are the snapshot documents. And for each document, I want to actually map it to something else. I want to grab its ID. And I also want to grab all the data that the document contains. And we're gonna see how that story is gonna make more sense as we go. So doc.data is gonna provide me with all the data in the document. And then I'm just gonna call my callback with those messages, because that's what I want to be displayed on the screen. So that's that. Now, how do I send a message? This is even simpler. So all I need to do is quite similarly grab the collection of messages. And there's a method called add here. So I can just say Firebase Firestore collection messages, and then I just want to add my message to that collection. Simple as that. These you want to be very careful with kind of promises, and because all of these tasks are asynchronous, you can see that my method here will be like, it might take some time. So I want to wait on this and kind of wait until this finishes execution. This one doesn't require that because that's just like a notifier. Actually, let's quickly check my auth service and see if I missed anything here. Actually, I did. So the sign in with redirect also is a synchronous task I want to await it on line 12, and similar with logout. Cool. Okay, I think we should be good. Now let's check and see if anything here changes. Actually, a cool feature, my login state persisted. You could see that I reloaded the page, but I'm still logged in as my account. I'm going to log out for now. Let's try and enter a message. Okay, we have a message of hello, someone. Let's check our database. I'm going to refresh the page. And here we go. We can see that we have a messages collection. It has one document with some random ID I don't care about. And it has like an author, a content, and its ID in my system, in the React system. Now, if I log in with my Google account, I will also be able to submit messages. Hi there. And we should be able to see that there's a second document right here, and it's actually stored my display name and the UID of my user. So everything works great. And the best part is if I refresh this, this persists. So this is pretty awesome, right? Like I have just connected some cloud storage system with my, actually, like I replaced my memory database with Cloud Firestore. The problem with this right now is that the messages will not be sorted. So if I just dump a bunch of more messages, just to demonstrate this, like for example here, right? Like the message just popped in some random order. That's because when we do on snapshot in here, the messages in the collection are randomly sorted. They are sorted actually by the IDs that are given to them, which are random when you add a new message on line 13. So what I want is I want to track when a message was added and then sort by some kind of a snapshot or timestamp of that message. And that could be done simple in here. But I want to showcase what Cloud Functions are. And actually what I'm going to do is I'm going to utilize a Cloud Function to run and update a document as it's being added to the Firebase. Let's talk a bit about it. So Cloud Functions are just bits of code that run on cloud. This is kind of your serverless architecture. You can just write a simple function, deploy it to some server, and then call it from anywhere you want. This is like super, super powerful if you want to integrate with anything else. And also very, very nice to, there's some custom triggers which you can include with Firestore. So let's see this in action. One drawback of functions is that this is a paid option for in Firebase. So when I'm going to be setting up functions, you will see that it's going to prompt me to upgrade the project. You can look for all the billing quotas on the website, on Firebase website. But they are very, very generous. Like you get millions of invocations per month. Unless you're building like a huge project, nothing to worry about there. So I'm going to select my billing account, connect all of that. It's going to send me some budget alerts in case something goes wrong. Yeah, that's just included my functions here. Now, similarly to how I initialized Firestore, I need to also initialize functions. So Firebase init functions. It's going to ask me what am I using, JavaScript or TypeScript. This is a JavaScript project. I don't want to use ESLint, and I do want to install dependencies right now. So let's see what this did. This actually included a functions folder in my application, which is a very simple kind of module, which includes your package JSON with all the different scripts you can run. But most importantly, this index.js. This is where all your functions are going to live. By default, it gives you like this default functions you can write, which when invoked will just log something like hello logs, for example, right? I want to go one step further. I want to show you how you can listen to specific Firestore updates and then update documents as they come into your Firestore. And this will actually look kind of as magic when we get this done. So I don't want to use this, but instead I want to create a new export. I'm going to call this on message create. And this is going to be a function. The type of function I want is the Firestore function. I want to listen to specific document updates. I want my messages collection. And I want any documents in that collection. So I can use this kind of template syntax to say that I'm interested in any ID that you're giving me. And there is a bunch of options I can check. For this particular case, I want to listen on creates of those documents. I can also listen to deletes, updates, writes. There's different hooks you can use. So on create, you will see that it gives me, I need to provide it a callback with two options. First being the snapshot, the state of the document at the point I'm like looking at it, and also the context, which will, for example, it will contain the message ID of that message. So I'm going to give it that and define my function. So what do I want to do? When I have a message created, I want to include a new field of timestamp that is going to update the document, and hopefully we're going to sort the documents by timestamps. So I want to grab my snapshot. I want to grab the reference to that snapshot, and I want to update that reference, to update that document. All I want to do, update function takes a new object of kind of key value pairs you want to add to your document. So all I want to do is I want to include a timestamp field, which will be equal to just a new date, and I'm going to get time from it. So that's going to give me like number of milliseconds since 1970 or something like that, but it's going to be equal for all the messages that I added. And important thing, you want to always kind of return something from your function. Your functions should not execute indefinitely. Be aware of this when you write your functions. Okay, fingers crossed. I think I wrote this correctly. I hope, because this will take like 2 or 3 minutes to deploy. But hopefully we should see that some timestamps are going through as we are adding messages. So what I'm going to do, I'm going to deploy this function. I'm going to say Firebase Deploy, and then I only want to deploy functions, because if you just run Firebase Deploy, that's going to also deploy your hosting and your functions and everything else, like any Firestore rules you changed on your development environment, everything. I just want to deploy the functions. Just double checking if I wrote everything correctly. I think that's fine. Let's do it. So it might fail on the first time. We might see an error. I was getting this when I was testing it. You might want to run it twice on the first kind of run through. Yeah, while that's running, I'm going to modify my front end to also sort by the timestamp. So I'm going to go back to the message service. And when I'm listening to the collection, I actually want to, oh, here it is actually creating the mesh create function straight away. Happens one at a time. Yeah, I don't want to just like listen to the whole collection. I actually want to listen to the sorted collection. So what I can do is use the sort by, order by method to order by a specific field in every document. So I could order by an ID field, or I could order by, I don't know, the name of the sender. But in our case, I just want to order by the timestamp. And this actually should do it. So when this function is deployed, we should be able to see that our Cloud Firestore will be, each document as we submit it will be updated with this timestamp, and they will be sorted by this timestamp. Let's see how our functions are doing. Actually, I didn't click get started. So let me just click through this. You can already see this function on here. I don't think it's finished yet, so I'm just going to wait until the console deployment finishes. Just a quick overview of what this is. You can see how many invocations you get of your functions, so like a very useful infographic. And you can see this with every service in Firebase. They are very transparent, like for you to track how much services is being used. Also, any logs that your function is going to output, any errors, or like, for example, if the function will fail right now, I will see the errors that I get. And like some health checks for your functions as well. So it's a very, very nice kind of overview of all the functionality you get for each service.
Hey, Andre, yeah. I hate to interrupt, but are we near a good stopping point now to bring everybody back?
If
I had a few questions.
You could give me 1 more minute. Hopefully this deploys and I can just show how that's working. Yeah, here it is. The deployment is complete. All I'm gonna do is I'm going to add another message. So you can see it's here, but now if I go back to my Firestore, I'm going to find where that message is. And here we have it, a timestamp that was added dynamically. So what the function actually did on the backend, it executed, took the reference to the message and updated it with this timestamp right here. So unfortunately, we're out of time, but if I were to delete all the documents and rerun this again, all of my messages would be kind of sorted by timestamp, and we would have like a chronological history of the conversation here. Yeah, I think this is a good stopping point. Sorry for going over time. I had like tons of stuff prepared, but yeah, I feared I would not squeeze it in, but that's fine.
No, all good. Hey, thanks for covering so much in such a short period of time.
Yeah, no worries. Yeah, thanks everybody for listening. If you have any questions, reach out on the chat, but otherwise, see you on the main stage.
See you. Thank you. Thank you, Andre.
Bye-bye.
All right, looks like we have everybody back. Thanks for joining again. Now, is everybody feeling good on time? We're almost done. We're at our last study jam. So does anybody want to break? If so, let us know in the chats. Otherwise, we'll keep on trucking through to try to get everybody out as early as possible so you have more of your Saturday to enjoy. All right, seeing no messages, we'll move on. I'd like to welcome Henry and Kelvin. Henry, I'll let you introduce yourself, but just a quick synopsis. Henry's going to be covering TensorFlow. We're really happy to have him. He's a GDE, Google developer expert. And then Kelvin is going to give us a rundown on React. It's going to be a great presentation too. So if you two don't mind introducing yourselves and a little bit about what you're going to talk about, and then we can break people up into groups.
Well, so I can start. Can you guys hear me good? Perfect. So yeah, I am Henry Ruiz. So I am currently research associate and PhD student in Texas A&M. And at the same time, I am like part of the machine learning Google Developer Experts program. So specifically in the machine learning area. And today I am really excited to show you guys how I start working and developing an awesome application with TensorFlow. So yeah, it's just what I want to say. I'm really excited. Thank you guys for having me here. And I hope this is gonna be useful for your projects and the kind of ideas that you're going to be developing in the next few weeks.
Thanks, Henry. We're really happy to have you join us. And so thanks for taking some time out of your day. Kelvin, you want to go ahead and introduce yourself?
Yeah, thanks, Bobby. My name is Kelvin, and I am the PR coordinator of the DSC chapter here in UW Madison. And yeah, I will be talking a little about React, just an intro, just to get things started. But yeah.
Great. And we'll do the same thing. So Henry will be room 1, Kelvin will be room 2. Change your name accordingly based off of which one you want to be in. But we'll randomize the groups at first, and then once we see your numbers, then we'll put you into the right rooms. So account for a little bit of jumping around in the beginning, but then we'll get everybody set, and we'll have about a half hour to go through these, and then we'll bring everybody back and close things up. So thanks for everybody's patience, and I'm looking forward to learning some more about TensorFlow and React.
Thank you.
Okay. Well, since we only have 30 minutes, we're just gonna have to skim through it all. Do you guys have any experience with React before?
I have some.
0? Or
A little bit, very little,
okay.
But a little.
Okay, but yeah, yeah. Let's. I'm gonna be presenting for a little while, just with several slides, and then we can get into the demo. We're gonna make a little to-do list for the demo. But yeah, so oops, it will be my introduction slide. I'm a computer science major. I'm also taking a digital studies certificate. And I'm graduating this semester. I'm currently working as a part-time. Currently, I have 2 sort of positions at the same place. I develop websites for a NASA pre-fire mission, and as I also work as a machine learning and data scientist for cloud detection. And yeah, I will be joining Bloomberg as I graduate. But yeah, so a little bit about myself. So React.js is basically a JavaScript-based front-end library by Facebook. JavaScript, the JavaScript is in quotation marks because Although, yeah, React is based on JavaScript. People using React usually use what it's called JSX, which is a type of language that combines both JavaScript and HTML together. So it has the advantage of being a full-fledged programming language like JavaScript, but it also allows you to write things down as an HTML type format, and it allows you to visualize things better. It's not really required for you to use JSX, but it is very much recommended because it helps you visualize the HTML UI components, and at the same time also use the powerful tools or libraries that JavaScript has. So the first example here is basically we have a constant name with the name, and then an element, a React element, which are basically objects in other languages, or like in Java you could it's equivalent to like an object in Java or C++. However, it's immutable, so you can't really change it after it's created. And yeah, you can also create functions that return the elements. So you can make your UI functional, basically. And yeah, some more examples of JSX is that it also supports HTML attributes. So like source, or like images, the image tag source, or the tab index. So it supports it, and yeah, you can customize the attributes depending on the variable in JavaScript. So that's a really neat feature. And it also has security features built in. It escapes the characters, so it's all safe. You can print it out and it won't ruin your HTML tags or the UI. So yeah, how do you render the output? So you would need at least 2 files. One is the HTML file that has the div with an ID that corresponds to the basically the element that you want to render your React element in. So in your app.js file, you would have a React element, and you can call React DOM.render and pass in the element and the root div object of the HTML. In usual cases, you wouldn't need to do this manually because React has a lot of different libraries that allows you to automatically create the files. And yeah, some examples are some examples include create React app. So you just pass in the just run create React app in the command line, and it will basically create all of the required files, and yeah, all of it will be ready to run. Some other React.js features include efficient updating. So React only updates what's required. So like, for example, here we have a function called tick, where inside we have a React element of the HTML tags we have. And then every time, so yeah, so set interval basically is a JavaScript, included JavaScript library that allows you to occasionally call the function. So in this case, it will get called every 1000 milliseconds. So every 1 second, it will update, it will call the function tick. And what happens is it will basically recreate the React element and change the current time, or yeah, change the current time and re-renders the element. And it automatically just change the required the element that's updated. So it doesn't change the whole element basically. So that's one neat little feature that React.js has for optimization. And yeah, so we've talked about React elements. Those are basically like little objects that are read-only. And now we can expand that idea and get components. So basically, components are like JavaScript functions, and props are the parameters of the function, right? So like the example that we have here, we have a function called welcome with props passed in, and it will return a React element with the parameter, props parameter. So if we have for example, okay, we have the component welcome, and it works as a HTML tag. So you can call welcome like an HTML, like any other HTML tag, and you can pass in the props this way. So in this case, the name attribute will be props.name in the welcome component function. So you can access it that way and print it out. So yeah, so this piece of code, like before, renders the element on the root element in the HTML. So, and you can also reuse components to avoid redundant code. So in this case, it will print out hello Sarah and hello Kahal and hello. Why are the names so difficult to pronounce? I don't understand. But yeah, it basically allows you to combine components together into a single component, and you can call the component the combined component together and render it to the root element. So you can nest components as well. Some rules on components and props. So pure in programming, you would have two different types of functions, especially in JavaScript. Would have pure functions where the functions don't modify their input parameters. So in this case, if we have this function sum, and the parameters a and b are passed, it basically just returns a new integer of that new sum of a and b, and a and b will be left on its own. It will remain the same. And on the other hand, we would have impure functions, and impure functions basically changes the input parameters. So in this case, we have a withdraw function that has the account parameter and amount to withdraw. And in this case, account would be a JavaScript object, and the total field from the account is subtracted by the amount. In this case, account will be modified, so account will be different. In React, React components must act like pure functions, so it should not modify the props that they are given in. So in previous case, we would have props.name. Here, you should not modify props.name because it's read-only and will cause a whole lot of trouble or problems, and will not be good. So what if we want to change the name, right? Because we want to create web apps that are interactive and sometimes depend on user input. So we want UI components on our website to be dynamic and can change, basically. So that's where states and life cycles comes in. So before we talk about states and life cycles, React components can also be represented as classes. It's better for you to represent React components as classes just because that it allows you to use states and life cycles. Because before in our React component function case, it's just a simple function that returns the React element, right? But we want to be able for it to have custom fields, constructors, and all of that things that classes require or allow you to have. So it works the same way like the function, but you have to write class, the name of the class, and extends React.component. So it needs to extend the React component class. And for the rendering, you just call the render function. It's basically just overloading React component, overriding actually React component render function. And yeah, so to pass in props before in React components, in the components in the function format, to pass in props, you just pass it into the function's parameters. But in our case, we have to create a constructor. So the props will enter through the constructor, and you have to call super to initialize the React component base classes constructor. it's required. It'll give you errors if it's not there. But yeah, so in the constructor, you would also have to, we want to initialize state, right? The state is basically like, if you think of an object in Java or C++, you would have fields that you can modify. So like if you would have, so like imagine a person object, right? You would have a field of name in string or age in integer. It sort of works like that. But it is stored in this single field called state, and it's basically a dictionary of the different fields. So if you would imagine in Java or C++, you would have a person object, but person object would only have a single field, which is called state, and it's a dictionary, and inside that dictionary you would have the different fields like name or int or for age. So that's what it basically is. It's also local to the component, to the current component, so it doesn't, you can't access it from somewhere else unless you pass it in as a prop to a child component. But yeah, so it works the same way as props for the return, for the render, or the HTML format that you have to put in to print out the prop. So instead of this.props, you would have this.state and .date, which gets the date. And yeah, it works the same way as props, but in this case, state, in this case, the date is modified. The current time that the component is loaded, so it won't change. It will just show the time of when the React component is loaded. So that's not a good thing because we want the clock to change. So what we will need to do is add lifecycle methods. So there are two lifecycle methods that are functions that are usually most useful. One of which is component did mount, which will be called after a component is mounted or rendered, and then component will unmount, which will be called when the component is about to unmount. So it would sort of be like if you have a try catch finally block, the finally would be like component will unmount. So yeah, we have all of that, and we can implement the component did mount function, which basically sets the timer with the interval that calls the tick function every 1 second. And the tick function will basically reset the state or modify the state of date, where it would create a new date object, and and React will automatically detect that the state has been updated, or the date state has been updated. So what will happen is in the return or in the render, it will basically re-render the this.state.date because React has this functionality where it would detect changes on state and update the state. And after, if we were to go on to another page or just do something else that needs this component to be unmounted, we can clear the interval so it won't keep running in the background. So it cleans everything up. But yeah, so there are some rules on states. You're not allowed to modify the states directly. So what you want to do is to use the set state method or function to edit it. State updates can also be asynchronous. So in the first case, this dot set state and then counter this state dot counter. React sometimes batches like combines different state updates together. So this first case, it might not work because the counter could be in a different counter or increment can have a different value than expected because it might be called later than expected. So what you would want to do is you could use the set state function, the overloaded set state function that receives a function that receives the current state and the current props. So in this case, the set state function will know what state to use, or like snapshot of the state to use, and the props to use as well. State updates are also merged. So in this case, we would have state of posts and comments, and updating the posts will only update the posts. It won't remove the comments or modify the comments. And the same thing will happen as well if you update the comments. So it won't. So if you only put posts in set state, your comments will still be there. It won't get removed or anything or modified. And yeah, makes things a lot easier. And you can also pass in the state as a prop to a child component. The child component don't really care. They will only see the date object that parent component has created. So it works like usual props. But yeah, so demo. Do we have enough time to do the demo?
I think we're running a little short, but I haven't gotten a message back saying that Henry's is done. Henry's, so I think we'd be too short for a demo now, but we have to, if Henry's ends, then I'd say we bring it back. Otherwise, we can keep going.
Yeah, so for the demo, I just wanted to show like the structure format that is usually found in React. But in usual cases, you would want to use create React app or Next.js or that other React app manager that allows you to build and run it seamlessly. But in our case, that's kind of a lot of work. So we could use Code Sandbox to just mess around with React. So in this case, we have a component called app, and export default is just basically exporting our app function, so it can be accessed by other files. So in this case, we have the index.html. We have the root div HTML element, and it gets rendered here in index.js. So in this case, we imported the app component from our app file, and we call react.dom.render and the component, which is app. So we could change stuff. So we could add world, and you'll basically it'll basically print it out. But yeah.
Nice. I like Code Sandbox. I haven't ever used Code Sandbox, so that's cool.
Yeah, it's pretty nice. You can test out stuff, which is pretty. It's also pretty powerful as well, because you don't need to do any of the like bells and whistles of like setting up your development environment. So you can just go at it.
That's nice. Yeah, I've used Repel.
So, okay, so what I mentioned before, my name is Henry Ruiz, and I am Google developer expert in machine learning, and I am also doing my PhD in Texas A&M, and at the same time working as research associate in the Department of Soil and Crop Science. I have been working for a long time developing apps, applying computer vision techniques and machine learning techniques in the field of the agriculture specifically. And today I want to show you guys how you can actually start by learning and developing apps using TensorFlow specifically. And we're gonna learn how to train an image classifier, and how we can actually deploy or use that model trained in our web apps. So this is gonna be awesome, and I'm gonna share with you guys the code. So let's start it. Here's all my information. Feel free, guys, to contact me. So I'm gonna be happy to answer your question, and I hope this workshop can be useful for you with the ideas of the project. Sorry for my dog, he's kind of like asking for attention. Okay, so let's start talking first before to move forward and start, showing the amazing thing that you guys can develop with TensorFlow. Let's discuss about what is intelligence. This is very important because so we're gonna talk about artificial intelligence. So I want to show up here the kind of relationship between the artificial intelligence and the kind of human intelligence, and how we can build intelligent machines. So this is gonna be a very short introduction about the topic, and then we're gonna move forward with the code part. So, okay, so what is intelligence? Intelligence, we can define intelligence like the ability to acquire and apply knowledge and skills. So this actually, there are different kind of intelligence. So depend of the skills that we have. So there are some people that are good for math. There are other people that is really good for music and this kind of stuff. So we used to be like very good in like one specific area or one specific, and this is actually why we decided, okay, I want to start I want to study computer science, or I want to study another stuff. But the question here is how we can build intelligent machines. So this is a really good question. And this is why I show here in this slide the different kind of terminologies that you gonna, found in the literature, and you're gonna kind of need to be familiar with before to start developing machine learning or artificial intelligence apps. And this is when you start learning this kind of stuff, these concepts are very confused. So let's start defining what is artificial intelligence. Artificial intelligence denotes any kind of activity where machines somehow mimic intelligent behaviors shown by humans or sometimes by animals or this kind of stuff. So this includes some research areas, kind of like a genetic algorithms, optimization, planning, computer vision, speech recognition. This is some of the research topics that involve artificial intelligence. So you're gonna find this a lot in there. Okay, so and machine learning is a subset of artificial intelligence, and this basically come with different models and algorithms that we can use to make your machines able to learn from data. So this is something very important. Machine learning is a subfield of artificial intelligence focused on make machines learn from data. This is very important. And deep learning is just basically a kind of models inspiring. This kind of algorithms are called by-inspired models, because those are actually inspiring how kind of our brain work, and we're gonna see later how this actually works. So if we want to make a definition of what machine learning is, so we have two definitions here, one for a general perspective, and another one more a specific. So machine learning, we can define machine learning like a discipline focused on how to build systems that automatically improve according to their experience. And their experience in this case means data. All the information that our transactional application that we develop can be used to improve how actually the solution or how actually the system works. That information can be used. And if we want to go more specific, so this consists in training a mathematical or a statistical model using the historical information to infer or predict the value of a variable. And here in these points, so this is very important because depend of the nature of the variable that we're going to predict. So is a classification problem or is a regression problem? And we're gonna see here what I'm talking about. If the variable that we want to predict is continuous, that means that this is a numerical values. We are talking about a regression model. So we're gonna try to create a regression model that predict that value. But if we have a set of categories, of classes, sometimes names kind of like labels. For instance, if I want to train a model to classify dogs and cats, so in this case, the output of our model gonna be discrete. And in this scenario, we are talking about a classification problem. This is really important to have in mind. But how actually these machines learn? This is another important thing. So depending on the kind of problems that we are trying to solve using machine learning or deep learning, so the algorithms or the models that we're gonna pick, there is a bunch of models available in the literature and the state of the art that we can use. So they learn depending on the problem. For instance, if we have a data set, when I talk about data set, can be a set of images, can be videos, audio files, or can be data presented in an Excel file. So when we have a data set and we want to just try to figure out if we can find some patterns in the data, you know, like we don't have kind of like defined and a hypothesis, means like we don't have clear what we're gonna do with that information. So we can go and try to like an unsupervised learning model. And how these algorithms actually learn. So you basically pass to them the input data with no label, no categories. And the model going to try to find some kind of structure in the data. We're gonna see what this kind of structure means, and then group them. So imagine that I have a data set of students in one university. I want to group them based on the kind of you know, different kind of characteristics or features. And we have other kind of models, which is like classification models, and these fail in the supervised learning. So in this case, we need to provide the samples with the labels. So that means that if we want to train a model to classify cats and dogs, we need to pass a bunch of images of cats, a bunch of images to dogs, to like you know, make the machine able to learn from the data. And there is another kind of problem that is the reinforcement learning. This actually, I can say that this is kind of actually a model that somehow learn in kind of in the same way that how human does. And one of the reasons I say that is because this is basically based on try and kind of like try, if you get an error, try again, you know, try, and so this kind of stuff. So you basically have an artificial agent. So this artificial agent can be either like can be basically anything that we want to like make that agent do something in like a specific environment. So reinforcement learning is very useful in the video games. So when you want to train like just think about if you have a Mario Bros and then you have this character that you want to train a model to you know, like to pass the game. This is a kind of visualization of the different kind of problems that we can have. So we have clustering, we have classification, and we have reinforcement learning. Okay, so but how our data need to be presented to the model? This is really, really important. And after that, we're gonna move and start working in the demo, and you're gonna understand a little bit what I am talking about. So in this point, what I want to show is that the data or data sets can be either an Excel file, or can be images, can be videos, audio files. So the data can be presented in different ways. But in order to like identify what we can use to solve that particular problem, so we need to somehow turn on our data into a vector representation. So that means that if I have images, how I can convert that images in a vectorial representation that allow me to plot that particular image in a Euclidean space. This is actually called Euclidean space. You know, like you have different axes. For us, is familiar, have two dimensions, X and Y, but in machine learning, we can have multiple dimensions. So that means that we have an image, we extract a set of features in the image, we create this feature vector, and after convert the image into a numerical representation, we can plot this into the space, and then we can actually see if the examples that we have in our data set can be separable using a linear function or not. You can see here, for instance, that a linear function won't be able to separate the data because we have a tree cluster of data. Just think about this is a cluster that corresponds to the dogs. This is the cluster that corresponds to the cats. And this is the cluster to correspond to other kind of class. And you see that here, using a linear function is not possible to make a separation. And I am talking specifically about classification problems. And how actually that works. So how these images can be converted into a feature vector. So you have an image and you can extract different features from the image. You can use very basic features like the mean, the standard deviation, and this kind of stuff. Or you can move forward and try more sophisticated feature extraction algorithms, similar to the algorithm that we're gonna use today, which is using convolutions. And the convolution specifically try to identify features like borders, like different kind of shapes in the image. And using those features, we're gonna have a vector representation of those characteristics. And we're gonna pass this into the model and we're gonna treat the model. In case of, this is an example where for a text data set, imagine that I have this text, this kind of statement, and I want to convert this statement to a vector representation. So I can use something that is called like a bag of words, where you can, when you assign the frequency of the word in that particular sentence, and you can create a vector with those values, a numerical representation of that text, and then you can move ahead and apply the algorithms. So just like for make an overall, so we have a machine learning. So we have mostly two kind of problems. This is the most known problems that we're gonna probably face: supervised and supervised problems. When we talk about supervised learning, is classification or regression models. When we talk about unsupervised learning, we are talking about clustering analysis. And this is the kind of algorithm that we can use. And this is an example. Imagine that a company asks to develop an application that take a picture of the flower and predict the class of the flower. So we take the picture here, we apply some pre-processing in order to improve the picture, color, contrast, or any other kind of characteristics that we can improve. And then we segment from the kind of regions or areas where we're gonna mainly focus. And then we move ahead and extract the features. So in this case, we can extract, for instance, the sepal length, the sepal wide, because after like make an exploratory analysis and make a visual inspection, I noticed that those features are enough to make a classification between the classes. And then I create my data set and I move forward and I pick the algorithms that I'm gonna use for solve this problem. So, but sometimes it's really hard to extract these features. Sometimes we cannot easily identify these features. For instance, for these problems was really easy because you can visually inspect the kind of images. For instance, this is one class, other class, and you can identify that only with those features that we pick, we are able to do a classification, a differentiation between the. But so sometimes what I'm saying is hard to get those features. So we have deep learning models, and these kind of models, what they're gonna do is internally they're gonna apply different filters into the image or kind of transformation into the image, and they're gonna identify features like borders, different shapes in the image. So that means that the model itself going to learn which feature need to use in order to solve the problem. So that means that the main difference between use a machine learning conventional approach with respect to deep learning is that the deep learning model have a feature extraction already implemented. So there are different tools to do that, to start working and developing this kind of application. We can go high level and use platform like Google Cloud, Azure, IBM. All of those kind of solutions already have a bunch of different machine learning algorithms implement. If you want to create a Python app, or if you want to create a web app that classify dogs and cats, you can use the Google Cloud Vision API. So you just need to upload the images, train the model using AutoML, and then you're gonna get the classifier, and you just call this API from your app. It's gonna be the easy approach. Or you want to go, if you want to go more in deep and try to implement by yourself your model. So there are tools like a kind of like a TensorFlow. You can use Keras, you can use PyTorch. And today we're gonna focus, there are different algorithms available to train our models to solve our problem, but we're gonna focus specifically on neural networks because TensorFlow is a Python package or a Python library that's going to allow you implement neural network very friendly way. So for that, we need to understand a little bit how actually this kind of model, I'm talking about neural network specifically, how this kind of model actually works. So we have our data and we have an score function. This score function going to tell us if the model is going well during the training or is going bad. And we're gonna have actually like a numerical representation of how much, how bad is the model. So we can use the loss function to see if the model actually is learning something or not. And we have a bunch of parameters that the model is going to learn itself. So that means that the model is going to extract the features and going to try to find the set of parameters that using an optimization algorithm is going to solve the problem that we are trying to create. So, and the reason why the neural networks are called by inspired model is because we're gonna have a bunch of layers, and these layers basically have a specific function into the network. So mostly the first layers, so gonna extract the features, and then you can actually see here we have 4 layers. So the first feature, the first kind of 2 or 3 layers is gonna mainly extract feature, and the other ones gonna be the classification itself. So that means that we're gonna have a bunch of inputs. These inputs can be any kind of feature that the model learned. And the model is going to try to identify the functions that allow to do the classification or solve the problem that we are trying to. Okay, this is how actually that works. We have a set of inputs. So imagine that I have the data set to classify flowers, and we have 4 features. So that means that there's gonna be feature 1 that can be the height. This can be the weight and the width. So we have different features here, and the model internally going to try to find these weights. So this weight is going to define. So, this way basically going to define those features which are more important. And then they're going to create a function. So I don't go into in detail in that. So I'm gonna share with you guys this presentation. So I have a few minutes left. So I want to go ahead and work in the demo. So there is a lot of math involved in how actually the neural network works. So next time I can go more in deep into the math behind of this kind of model and how these models can be implemented from scratch. But today I really want that you guys get familiar using TensorFlow, because TensorFlow actually make easy the implementation of this kind of model, because you don't need to think about the math part. You just need to go right ahead and train your model. And there are different ways to do that. And TensorFlow, the good thing about TensorFlow is, and this is actually the excited part, is that TensorFlow offers you all the tools you need to train your model, but not only train your model. TensorFlow gives you the tool to deploy the model in different environments. So for instance, if you train your model, you can take that trained model and deploy that model in the browser. You can make the model run inference directly in the browser, or you can put this model in an Android app, or you can put that model into a server, and you can create an API, and you can call that API from different applications. And there is a bunch of different already trained models. So there is something that is TensorFlow Hub. I'm gonna show you the link. And you can go there and you're gonna find different models to do classification, detection, style transfer, and all of this cool stuff. So I'm gonna close here and I'm gonna move effect with the demo. So the demo today, we're gonna learn how to develop classifier of cassava diseases. So we're gonna use first the high level API, and we're gonna then make an example using the low level API. And you can have a kind of like a view, a better like kind of idea what kind of things you can do with TensorFlow. Okay, so let's start. So this is a Python notebook. If you never have used Jupyter or this kind of tools, a notebook is basically kind of like a file when you can embed code, but also text. This is very useful to create reports or this kind of stuff. So I'm gonna put here the link. You can just go and put Google Colab. This is free, and the good thing about Google Colab is that it's automatically connected with your Google Drive. So that means that when you create a notebook, that notebook is going to be in your Google Drive. So I'm gonna create a new notebook here, and I'm gonna put here demo one. Okay, I'm gonna increase this size a little bit. So you're gonna see here that you can upload files, you can upload your data set. So by default, you're gonna find that there is a sample data here that you can use it, different kind of data set that are known. But we're gonna, in this case, work with images. So what I'm saying, so you can go and check TensorFlow Hub. TensorFlow Hub is a really cool place where you can find different models, and those models are already trained. So you can just like pick the model you want to use and use that in your application. So there are different problem domains here. For instance, image segmentation, image classification, and you're gonna find here a bunch of different models. And if you go into them, just pick this one, image classification, and one of those. You're gonna actually learn how to use those models in your application. Let me see if we can. Yeah, you're gonna find how to use the code and everything. Okay, so we're gonna learn the basics of TensorFlow today. I know that we don't have so much time, so I'm gonna try to go fast, at least with the basic demo, and then I'm gonna show you the more complex one. I'm gonna go through the line by line, and you can a little understand how actually TensorFlow works. So the good thing about Use Colab, what I mentioned before, is that Colab is one of the Google product. So that means that you're gonna find there pre-install all the tools that you need, all the packages that you need to start using TensorFlow. So I can actually check if TensorFlow is already installed. So I can just say, this is another cool thing that TensorFlow Colab has, that I can run like a terminal commands in the notebooks. So for instance, I only have this file here. I can do any kind of command. Okay. And to install packages, I can use pip. Pip is a Python packages index, so you can use this tool to install Python packages, libraries, and in your environment. So you're gonna and you can check if there is one particular package already installed there. So you're gonna check here pipe show TensorFlow. Okay, and I'm gonna see the description of the package. So what is the current version that is already installed? Is the 2.41. And also I'm gonna check what is my Python version. So I'm gonna say Python version. So the version that is running in this current notebook is Python 3.7. Another good feature that Collab has is like you can change the runtime. Right now, this code is being run in the CPU, but you can change the runtime type here, and you can run in the GPU or in the TPU. We're gonna go ahead and set and pick GPU here because we're gonna use the GPU, and I'm gonna continue with our example. So for this particular demo, we're gonna need to install two libraries. One is called TF-Lite Model Maker, TF-Lite Model Maker. And so what this library allow you is basically trained image classifier or like a natural language processing model in just a few lines of code. So you can go and check the documentation of TensorFlow Lite Model Maker, and you can also export that model into to be used in the mobile or you can also use that model in TensorFlow. Okay. So I don't know how much time I have. So
oh, I'm off mute. Yep. So we're kind of wrapping up on time. If there's a good natural stopping point, otherwise, if everybody's happy with staying on, take as long as you'd like, Henry.
okay, so I'm gonna go fast through this demo. So I actually gonna just explain the code, in order to speed up a little bit the process. So first, what we do here is import the libraries. So for this particular demo, we use TensorFlow and TensorFlow dataset. TensorFlow dataset is actually a TensorFlow tool that have a bunch of different datasets available that you can use in your projects. You can check it out this in the documentation of TensorFlow, and you're gonna find this catalog here. And there is a different dataset for image classification, object detection, audio, question answering, and any kind of model that you guys want to like implement. So we check here the TensorFlow version, what we did we did before, and we install the package that we need for this demo. What I'm saying is we need a model maker and the TensorFlow dataset. So finally, I check here that there is actually this notebook is running the GPU. So I run this command and I'm gonna see that there is already a GPU attached to my notebook. And this is how you can actually load dataset using TensorFlow datasets library. So you can just say TensorFlow dataset load, you specify the name of the dataset, you take this name from the catalog, and here is the split. The split means like you're gonna get the train, validation, and test, because we need to train and validate the model using the first two datasets or subsets, and then we're gonna use the test to check if actually the model is working well. So this is how we load the dataset in memory. So TensorFlow dataset also have some visualization tools that allow you to basically show some of the images. For this case, you can see some of the images. Then we import TensorFlow Lite Model Maker. This is the other library that we installed before, and we create an image classifier from a TensorFlow dataset. We specify the name of the dataset here, or we can just pass a folder path with the images that I want to use for my classifier. If I want to classify cats and dogs or another kind of things, so you can put the images in a folder and you can specify the path of the folder here. So then you create the classifier. Sorry, you create the data loader here, and then you create the classifier. And when you call the create function, so the model going to start training. So I specify here that I want to train my model with only 5 epochs. And I passed the validation data set because the validation data set is gonna be used by the model during the training to check if the model is learning actually something or not. And you can visualize here in each epoch, which is the validation accuracy and what is the training accuracy. So you can actually see that in the first epoch, just like there are just kind of like random values, but after that, you can start getting like very similar values between training accuracy and validation accuracy. So we can evaluate the models in order to get the accuracy of the model. This is very important because we need to know and report, like how well my model is performing. So that's means that we can use these 2 metrics, the loss and the accuracy. And we can do some predictions. And here to do prediction, I just call the function predict that. And I pass the test dataset. And I get an array with the prediction back. So here in this block, this self, I am just doing some visualizations of the predictions. And you can see that the model for this image gets grown. Probably because there is a lot of change. There is a different kind of, in the image, the background is kind of different or this kind of stuff. This can like make the model make wrong decisions. But here you can see that the model do a good prediction with 0.8 probability. And here also was good, 0.7, 0.6. And you can check here the rest of the images. But the most important to point out here is that you basically train a classifier only with 2 lines of code. So you don't need to, this is using what I'm saying, this is using the high level API. If you want to go and implement the model by yourself and use more complex kind of layers or this kind of stuff. So I'm gonna share with you guys more sophisticated examples when you can define actually the loss function, the accuracy function, define the model architecture and topology by yourself. But this is just to have something to do, to have something to like have a model in a few minutes and put this in like a mobile application or something. So when you do the predictions here, so the next step is just export the model, and TF-Lite model maker is gonna give you different formats to export the model. You can export the model in like on a safe model, and you can put this model in a server, and you can create an API using Flask or another kind of tool that use that model trained. And this is the folder where the model is storage. Or you can also export the model for TensorFlow.js, and you can actually integrate this into web app. If you use React, or if you use Vue, any kind of, or Angular of any Vue or any kind of front-end framework, so you can just copy the generate files. You're gonna, I don't know if I can see, I'm gonna show you the kind of files that are generated, and you're gonna copy this into your project, and that's it. Or you can export the model for TF-Lite, and TF-Lite is if you want to develop an Android application or you want to develop an iPhone application, iOS application, you can take the TF-Lite model that is generated by these 2 lines of code, and you can make your app able to predict something, to predict, classify images, detect objects, or this kind of stuff. So, and here I just export the files and incorporate those files in my application. So you can see that was just, the hard part is actually this 2 line of code, image classifier from create the data loader that can be either from a TensorFlow dataset of a folder, and image classifier create. These 2 lines of code make the magic happen. So this is the very basic example. And I'm gonna go fast for the other one. It's just gonna take like 5 minutes. If you guys want to use the more the more low-level API. This is another example that I'm gonna share with you guys in GitHub. The same, in this case, you need to import TensorFlow and TensorFlow dataset, but also you need to import Keras, because Keras is the high-level API that have different kind of layers and that you can put in your model. So here you load your data set. In this case, for this particular demo, we use TS flowers. I don't gonna root each cell because they used to take some time, especially when the training is doing. So I just want to like go to the cells and you can have a kind of idea how this works. You can, so when you use the TensorFlow dataset library, this is gonna give you the split. So that's mean that this is gonna split your data in train, validation, and test. So I am saying here, I want to, for my train data set, I want to get the 80% for training. I want to get from the 80% to the 90% from validation, and from the 90% and the rest of the data for text. And I'm gonna get also the metadata of the data set. So using the metadata, I can know the classes. So where is the link where I can get more information about the data set and this kind of stuff. So here I just take for my train data set 4 images. I use the take function and I just plot them using matplotlib, and this is the result. So in this kind of cell, I wanted to show how you can actually visualize how internally the model extracts the features. What I mentioned is this kind of model, I'm talking specifically about classification models, does internally is apply different kind of transformation on the images in order to highlight features like a border. You can see here different features. Here you can see another kind of features. And the model uses those features to learn the function that are going to classify this data set. In this case, these are Flowers data set. And you can also in the model incorporate something that is called preprocessing layers. So that means that you have your model with the core layers. The core layers are gonna be the convolutions, the feature extraction layers, and also the classification layers. But you also can incorporate the preprocessing as a part of the model. So that means that you can have in the top of the topology of the model, some layers that are going to take the images and going to do the resizing. So that means that your model is gonna be able to accept different resolution images, okay? So here I basically, the code is well documented, so you can go line by line and check what's happening each line. This is a little more complex to digest because this is using the more sophisticated API, but you can go and you're gonna feel that it's actually not that hard. TensorFlow facilitates a lot of stuff. And here is when actually you create the model. So you say, okay, I want to create a convolutions, and I want to I want to apply 16 different filters with a kernel size of 3 for the images. Then I'm gonna have another kind of layer that is max pooling 2D, which is this kind of like a focus the feature that have been extracted in previous layers. So you can go on to the TensorFlow documentation and check more in details what kind of feature you're going to get back from each layer. And once you extract all the features, you need to flatten. When you do the flattens, means like I want to get all of those features and I want to create a long one-dimension vector, which is gonna be my vector of features. Okay, so then I just compile my model. I define the optimizer. I train my models. If I want to see the topology of my model, I can say model summary, and you're gonna see all the layers here and the input of each of them. And you just go ahead and train the model. So I trained the model for 20 epochs here with the data set. And I can visualize the metrics. For instance, the training loss, the validation loss. So you can see that validation accuracy increase when the epochs also increase. So that's mean that when the model started training and it started getting better and better and better in each epoch. And then finally, so you can use the model to do inference. I explain here how to do that. So I get a new image here from the internet, and you can get the file. You can apply the preprocessing that you define for your model, and you can do predictions, and you can get back what is the class. You can say this image which most likely belongs to the class, whatever you can, the model predict. And finally, you can convert the trained model to TensorFlow.js. This is the awesome part. There is a converters. This is a TensorFlow.js package that you can use to save your model in the TensorFlow.js format. And when you do that, you just download this into your application, and I'm gonna show you here the results. So this is a mobile application that I developed in just plain HTML and JavaScript. And you just need to import in your assets the model, the train model. So what the TensorFlow.js converter going to generate is this file that you can see here. I'm gonna try to increase the. You can see here the files that are going to be generated by the TensorFlow.js converter. You put this into a folder, and this is the most important file, the JSON file, because the JSON file, this file that you can see here are the weights of and the parameter that they actually the model learn, and this model JSON is just the map of those files. So you're gonna see that it's a JSON file that have all the layers and which is the file where the weights were serialized and everything. And when you have these files there, so you use in your HTML, you load TensorFlow.js and TensorFlow converter. And I create a button in my here in my HTML. I create a canvas when I'm going to draw the image, and I create a file input when I'm going to load the new image that I want to classify, and I create a button that when I click that button, I'm going to call the model to do the inference, and then I'm gonna get the class back. And so I just this is my main function. I define this kind of like a main function. It's an asynchronous function, but you understand a little more this kind of stuff that the kind of Python things that I showed previously. So then here you reference your button, you know. So you just basically say to the DOM that I want to use this button. So this create a reference in memory of the button in the application, and the same for the file and the canvas. And here is actually how I can use TensorFlow to load the model that I trained using Python. I just say load layers models, and I pass the JSON path to the train model. And when I click in the button classify, so I'm gonna convert the canvas into a TensorFlow, into a tensor. So I can use this function TensorFlow browser from pixels. I resize the image to the dimension that the model understands. And I just call the predict function. And I get the prediction back, and I show them in the console. So I'm gonna show very fast this stuff. And I think that this is all that I wanted to. So this is the flowers classifier. This is just the basic interface. When I reload this is the output of the model summary. When I call this function here, model summary. So this is gonna be the output. All the layers is kind of the same output that you're gonna get in the Python code. And here you just choose the file, the image that you want to classify. I'm just gonna classify this on flowers. And you click in the classify button, and you get the class back. And you can try with any kind of image. Let's try with so for this demo, we use, what is the data set that we use? We use tulipans. I'm gonna find a dandelion in Google. I'm gonna try to do the predictions. I'm gonna find, just try with this one. I'm gonna save this image. You can notice that doesn't need to be the same size, that because internally, because in the code, in this line, when we call resize by linear, we are resizing the tensor into the dimension that the model accepts. So you don't need to. Okay, so I'm gonna get back here and I'm gonna choose the file, Dandelion. This, I load this into the canvas first before to do the classification. And then I call the classification, and this classification is like a daisy. I don't know what kind of flower this does. Yeah, so get kind of like confused with that. So this is probably because I trained the model only for 5 epochs or 10, I think. So you can improve the performance of the model training the model more. And this is the display image. This is the function that actually visualize the image in the canvas. So there is a really cool stuff to go in, you know, like to go in deep here, but we don't have so much time. So I'm just gonna share with you guys. This is the GitHub repository with all the examples. This is my GitHub. And here in TensorFlow.js, you can find, there is a Python to 2JS folder here. You can find here the notebook where the model is trained, where the model to classify the flower is trained. And here is the HTML, where have all the code to load the image, do the inference, use the model and all of this stuff. And if you guys want to go more in detail about the TensorFlow concepts, there is a folder here, TensorFlow Core, and it's divided in different sections. It starts from explain the basic structure of the neural network that is the perceptron. So you're gonna find here what is a perceptron, which is basically a model with one neuron. The perceptron is basically only one neuron. You can find here how you can use a perceptron to do that. And this is from the most basic stuff in TensorFlow to the more advanced that shows how incorporate different kind of data into the model. So this is all that I have to say. So I know that this is a lot of information for like 30 minutes, but if you guys have any questions or just let me know, you can contact me through the Google developer groups, or you can also contact me in LinkedIn or directly in GitHub, you know, like making an issue or something. So I hope that this information can encourage you guys to develop cool things using TensorFlow. So probably this is kind of scary the first time when you see a lot of things, you know, going on, tensors, converting, you know, like matrices to tensor and this stuff. But TensorFlow have a lot of functions that facilitate that. So, and you guys probably are familiar with other kind of tool like a MATLAB or this kind of stuff because you have seen that in class. So I think that you're gonna be able to handle those concepts. Okay.
Great. Hey, Henry, thank you so much for the great presentation, for breaking it down for us too, for those that, you know, haven't used TensorFlow before. So it was a great introductory course. Before Henry heads out, does anybody have any questions for him? If you know you want to ask him personally, like you said, you know, reach out via LinkedIn or GitHub. But hey, Henry, thank you so much for taking the time and for being flexible with the timing of this as well, and teaching us all about the basics of TensorFlow. Thanks so much.
Okay, thank you guys. Bye.
Bye,
Have a
Henry.
good one, Henry. Bye.
Okay, bye.